Hello, everyone. Welcome to this free webinar presented by WePast. I'm your moderator, Christina Ruiz. During this webinar, feel free to use the chat to ask your questions and discuss the topic. We will take time after the presentation during the Q&A to answer these. Throughout the webinar, we will stop the presentation to review. Look for the multiple choice review questions, which you will be able to answer in the polls section. Please go ahead and respond to these questions as they come up. You will have less than a minute to answer each one. This and other recorded webinars are available to WePast subscribers 24 hours a day, 7 days a week. Be sure to register through wepast.com to become a subscriber. Today's topic is titled, What We Need to Know About Radiation Oncology IT, Part 1, presented by Feng. Mr. Feng is the Chief Medical Physicist of Radiation Oncology at the St. Barnabas Medical Center in Livingston, New Jersey. Thank you for joining us, Mr. Feng. I'll turn it over to you.
Thank you, Christina. It's a great honor for me to able share my experience on the Radiation Oncology IT. I used to have a computer engineering master degree and working at the radiology. And then at the same time, I got a medical physics degree and then become a metaphysicist in radiation oncology. So this is my personal perspective view of radiation oncology IT. If anybody have some questions, concerns, suggestions, feel free to email me or call me. My email address and phone number is listed. I'm very happy to share my experience and also hear your stories. It's always a great fun to talk to colleagues. There are two objectives for this seminar. One is first share my personal knowledge and experience for the radiation oncology IT can be used for clinical practice. Most importantly, is prepare some knowledge for the ABR exam. Here the outline. First part will be computer. The next we'll talk about the network. If we have a part two, I'm going to talk about the DICOM RT, HL7, and PACS. First, let's start with history of the computers. This is a graph from the Time magazine. We always talk about computer history, and computer history is not the same as the other industry. We have a exponential growth on the computing power starting from almost 100 years ago. The famous Moore's law said the transistor will double approximately every 2 years. So basically, that's a potential growth. In my setting, the real booming of the computer starting from the IBM PC in 1981. And then the computation power increased and the size of the computer decreased. That correlate the booming of our radiation oncology. First, let's talk about the computers. In history, there are multiple types of computers: supercomputer, mainframe, workstation, microcomputers, and microcontrollers. Of course, we always using the workstation and microcomputers in radiation oncology. However, this category is based on the computation power, but in a specific time point. This is a graph I got from the top 500 website. This is talk about the rapid growth of supercomputer performance. Let's take one example. In 1993, Intel built a supercomputer. The total computing power is 142 gigaflops. In 2020, last year, Intel released a i7, have 8 core and 5 gigahertz. It can generate 160 gig flops. So that means a consumer-grade computer in 2020 have more computation power than the supercomputer back in 1993. So 30 years, the computation power increased dramatically, which enabled our radiation oncology booming in the past 30 years and come to the current state. Now let's talk about the processing type. There are 3 types of processing type typically. One is a serial, basically performing the task sequentially. Second is performing the task simultaneously, so parallel processing. A special one called array processing, or somebody call it a vector processing. Basically using a dedicated hardware for a specific task. A common example is the CT MRI reconstruction. This is a reconstruction board for an MRI scanner. Nowadays, the GPU become popular and blur the edge between array processing and parallel processing. When we talk about hardware, we need to talk about the virtualization because virtualization becomes so popular nowadays. What is virtualization? Basically using a software or called a hypervisor to abstract physical resource and emulate different virtual hardware. This virtual hardware called a virtual machine. And so we have some physical hardware. Operationally, we can have operating system run on the hardware, or we do not need operating system at all. Then the hypervisor will run on top of the hardware. The hypervisor will create individual virtual machines. This virtual machine is separated out. Each virtual machine can run different operating system, also can run different kind of applications. The biggest advantage of the virtualization is it's easy to scale because the application and the guest OS is independent of the hardware underneath. So if I upgrade the hardware underneath, will not affect the virtual machine on the top. So the hypervisor basically separate the hardware and the virtual machine, make easy to scale and easy to migrate, and also easy to do the snapshot backup. Of course, everything comes with the cons because the hypervisor translate the virtual machine to hardware. So during this translation, there are some resource overhead. And also, since this hypervisor is coming from commercial companies, so need a license, so license cost. There are 3 major vendors for the virtualization. One is VMware. Second one is Hyper-V from the Microsoft. Third one is the Citrix. And for typically most servers can be virtualized. For our like wiring servers, all of them can be virtualized except the fast servers, because the fast server is the FDA controlled medical device. Can only purchase the hardware from wiring. And another typical software we use is Citrix, the Citrix virtual app and virtual desktop. That typically using for the client. Basically supply a secure universal remote access to application and desktop. This typically hosted in a data center or in the cloud. In the clinical environment, typical setup is using Citrix SynApp on top of the VMware. So VMware supply the virtual machine, Citrix SynApp supply the remote access. Let's do not confuse with Microsoft Remote Desktop. This is a tool embedded in the Windows that can be used for local access, but this remote desktop cannot run remotely. For example, if you try to run from home to connect to the hospital, typically not working. One workaround is, as this figure showed, we can put this remote desktop tool inside of Citrix, so publish as a Citrix app, then bypass this limitation. Since we already talked about the virtualization, the next step would be cloud computing. It's also popular nowadays. What is cloud computing? Basically, it's on-demand access, typically via the internet, to the computer resource hosted at a remote data center. What can be hosted remotely? Applications, servers, and data storage can all on the cloud. Even some developing tools and networking can be put on the cloud. The big advantage of the cloud computing is requires less IT resources. For example, when we purchase hardware initially, it's a big investment. If using cloud computing, we only pay what we are using for this period of time. So the initial cost is much lower. Also, there are no periodic refreshment cost, IT staffing, IT expertise. And the other advantage is the cloud computing is highly scalable and rapidly elastic, as long as we can pay the cost. Of course, the big disadvantage is when we're using cloud computing, we rely solely on the internet access. If the internet is not reliable, then our treatment will be slow, and also planning will be slow. So that is something to be considered. Another problem is if the cloud service failed, will affecting many clinics, not only one anymore. That tends to be happening frequently nowadays. Everybody heard about the story from the Amazon or the Facebook. And here is another disadvantage I always mention to our IT, joke with them. Local IT tend to be very reluctant to collaborate because they are worried about their job security. So if you have a strong local IT, tend to be a big issue on the cloud computing. Talk to many friends regarding their experience on the cloud computing. There are a couple of things they are sort of contradictory. One is lower total cost. Actually, lots of people using the cloud computing and then later on pour out and host everything locally by themselves. And also there are people changing from local hosting to cloud, and they were happy about it. It seems contradictory information. And lastly, do we really want to put all the egg in one basket? So we rely on somebody else. With that said, we have two major Radiation Oncology cloud computing vendor. One is the Lecta Access. Everybody heard about that story, the ransomware by the Lecta Mosaic Cloud. After this cyber attack, Lecta using Microsoft Azure as the basis. Virion, on the other hand, have their own cloud computing called Full Scale. Everything is managed by Virion at this moment. The ARIA, Eclipse, and Velocity all can host it and access on the cloud. Interestingly, Virion is collaborating with Google to build an AI-based diagnostic platform. So our Radiation Oncology tend to impress the other major vendors to back them up. Now let's back some basic information. What's the component of the computer? Computer have CPU, memory, monitor, peripherals, storage, archive, and software. We are going to talk about it one by one. CPU stands for Central Processing Unit. Everybody familiar with that, so I want to point out within CPU there are registers. That's basically the fattest storage within CPU, and also have cache. That's the second fattest storage within CPU. And when we talk about the performance, there are some benchmarks. One is called MIPS. It's million of instruction per second. The other one is FLOPS, floating point operation per second. And when we compare computation power, some people use MIPS, some people use FLOPS. That's the two of the benchmarks. Let's talk about the memory. Sometimes memory is called RAM, which basically is a random access memory. We can subcategorize into different, just for your information, potentially is called ROM, read-only memory. That's mainly for the BIOS or the firmwares. Storage. There are two major types of storage. One is called a hard disk. Nowadays, the capacity can be from 1 to 10 terabyte. Rotation speed can be as high as 10,000 RPM. There are different kinds of interface. The IDE, integrated drive electronics, is already deprecated. Nowadays, almost nobody using that. Currently, SCSI and SASA is the two major interface. When we talk about storage, we must talk about the solid state drive. There are three types of form factor. One is M2, second one is SASA, third one is micro SASA. So the most common one is this M2 form factor. That's using pretty popularly. Compared to the hard drive, the solid state have much higher performance, about 5 to 10 times faster, and much energy efficient because there are no mechanical movement anymore. There are no spinning. Of course, because it's so expensive, so it's much less capacity. When we talk about capacity, we always talk about the byte. Computer is a binary system. It's a 0 and 1, it's called a bit. Typically, we write at the lowercase. We already have byte. Byte equal to 8 bit. Typically, we write at uppercase. In the binary system, we have kilo, meg, gig, terabyte. That's all scaled by 1024. In the decimal system, also have kilo, meg, gig, terabyte. That is scaled by 1000. It's close, but about 2.4% difference. So we always confuse when should we use in decimal scale and when should we use in binary scale. For example, we have 100 gigabyte hard drive. This is the vertex capacity. In reality, is only 93.1 gigabyte if we're using the binary scale. So in that sense, whenever we talk about storage, we always using the decimal scale. And also pay attention when we talk about bit and byte. Byte always uppercase and bit typically always lowercase. That's something we always make some confusion. Another confusing part is the difference between storage and memory. In the old days, it's easy to differentiate. Now, since we have the SSD and memory and storage, basically the same type of technique, but still as the function is separate out. Like we have an iPhone, the capacity is 128 gig to 1 terabyte. So this capacity is equal to storage. Its memory or its RAM is only 4 gig or 6 gig, depends on the configuration. Here is the real-time story I encountered a couple of years ago. The server complained that the image cannot transfer from the Linux to the Mosaic. Then the error said storage location is unusable. Then check the storage, find out the capacity is 1 terabyte, only 45 megabytes left. So cannot even hold a whole set of cone beam images. So basically the storage is full. The solution is simple, increase the storage space. In the meanwhile, we delete some junk file temporarily so the system can continue running. So this is a good habit to keep some junk file in the system in case when these things happened, we can delete the junk file and system can function temporarily. And of course, IT or ourselves, we need to monitor the free space carefully. Here, another story. And during the trial round, the distribution complained that can only open a limited number of plans. The error message, there are not enough resource to complete the operation. Save your work, close other program, and then try again. Then you find out actually the system only have 8 gig of physical memory. Of course, because Windows 10 itself occupies about 4 gig already. So the solution is very simple, adding another 8 gig of physical memory, or just increase the virtual memory. Let's talk about the RAID. RAID is a short term of the redundant array of invasive disks. There are 3 typical RAID configurations. RAID 0 is separate the data into two disks. Read one is mirror the data into two disks. Each disk have exactly the same copy of data. Read file basically get both advantage of the read 0 and read 1, strip the data spread out into all the disks. In the meanwhile, create a parity of the stripped data. So now, if one disk failed, we can always reconstruct data back from the parity and keep the data in integrity. All right, here's the story. We found out one of the disks on the pinnacle read flashing amber. And the cause is this is the warning of this drive is failing. Of course, in the meanwhile, this read performance now is degrading. The solution is simple. We force this hard drive offline, delete the hard drive, replace the new one, reformat, and then just rebuild the read file. Everything back to normal. Let's talk about the archive. Everybody knows the CD-ROM and DVD-ROMs. They're in about like a 10, 20 years ago, there's other type of disk called the worm. Write one, read many optical disk. And the other one is a magneto-optic read-write optic disk. They look like on the right. Of course, we have the tape. There are three types of common use tape. One is LTO, DDS, and DLT. When we talk about this storage and archives, the hard drive, solid state drive, and memory cannot be removed. And the capacity are different. Access time different. The highest access time with the tape, and the shortest is the memory. Careful, that's a nanosecond, not millisecond. The other part component of the computer is the motherboard. Basically, motherboard is the basis of everything assembled together. When we talk monitor, nowadays there are three types. One is the CRT monitor. It's not available anymore. And commonly used one is the flat panel display. The OLED display is become popular at home, but not widely used yet in oncology. Software, when we talk software, we have operating system and also have our applications. Let's talk about the encoding. When the computer first come out, we always using the ASCII format. ASCII only have 1 byte. It's the standard for years. But when we're using computer in the other countries, it's become a problem because 1 byte can only hold so many characters. So coming out the Unicode later on, the Unicode have 2 bytes, can hold much more characters. Then come out the UTF-8. UTF-8 is a variable length, so backward compatible with ASCII. That's the most commonly used nowadays. Here's another story. The Mosaic 2.6 default using Unicode. However, our TrueBeam 2.7 is not. So it caused quite some communication errors. So the solution is make the two using same encoding. Let's talk about the endiness. There are two types of ending. One is the big ending. It's used in like some workstations. Little ending typically used in the Intel computers, like Eclipse. What happens is, if we transfer image, especially raw images, between different ending systems, sometimes we cause troubles. This is a normal big ending image. This is a big ending image depicted as a little ending. You can see the image is garbage. So when you see the image is not right, that something can be checked. All right, let's practice some questions.
Okay, great. I just put this poll up. So if everyone who has joined, if you could go ahead and find this question in the polls section, you'll be able to answer it live. And once everyone has had a chance to weigh in, I'll have Vijay go over the correct answer. Do you want to just state the question for everyone?
Right. List the following in a typical access time, slowest to the fastest. Floppy disk, hard disk, solid state drive, and tape.
Okay, we'll give everyone just a few more seconds to answer this question since we're still getting some responses, but it looks like most people are getting the correct answer. I think if you want to go ahead and review the correct answer, we can go ahead and do that.
So the correct answer is C. So the slowest is the tape, because tape is in reals, need to rewind, and also the linear access. Second one is the floppy. Floppy need to put in, take it out, and also slow rotation. Next one would be hard disk. Hard disk can rotate like 10,000 RPM. The quickest is the solid state drive. It's like a memory. There no mechanical part. It's all electronics. So correct answer is tape, flop disk, hard disk, and solid state drive. So correct answer is C. All right, another one.
All right, go ahead.
Concerning digital computers, all the following are true except ROM stands for random order memory, RAM stands for random access memory. A word is a consistent byte treated as an entity and occupying one storage location in memory. A byte contains 8 bits. A modem is a device that converts digital signal into frequency encoded signal for transmission over analog line.
All right, great. This poll is up in the polls section, so I'm going to give everyone just another minute to go ahead and answer this question as well. And once most people have put in their answer, we'll go ahead and review. All right, great. I think we can go ahead and go over the answer.
All right, the correct answer is A. do not forget the except. So the ROM is stands for read-only memory, so not random order memory. So the correct answer is A, even it's wrong. Parallel processing refers to running multiple tasks simultaneously, running multiple processors to increase speed, cluster of computers interconnected by networking, using KVM to share peripheral devices between computers.
All right, great. This one is also up. It looks like folks are getting the hang of it and answering this question. It seems like maybe it's a little more challenging. Got more of a variety of answers here. Just give everyone another moment to answer this question. All right, let's go ahead and review the answer.
All right, the correct answer is A, running multiple tasks simultaneously. And for the purposes, there are many ways. One is using multiple processors, or using cluster of multiple computers, or even using multiple core within single processor. So B and C are part of the parallel processing, or one type of parallel processing. D basically is nothing to do with the parallel processing. What's really parallel is our mouse or keyboard is parallel. The computer is not parallel. It's our input is parallel. So correct answer is A. CT image acquired with 512 by 512 and 12-bit pixel value. Approximately how many can be stored on a 4.7 gigabyte DVD disk, assuming integer byte used for each pixel?
All right, great. This one, next question is up in the polls section. We'll give everyone just a moment to go there and answer it live, and then we'll review the answer. And I also want to remind everyone that if you have any questions for Vijing about this presentation, please go ahead and make sure to put those in the chat so that we'll have a few questions during the Q&A. That'll happen at the end of the presentation. All right, we'll just give everyone another moment to answer this question before reviewing. Okay, I think we can go ahead and go over the answer.
The trick point is for CT, we typically using 12-bit, but it's stored in 2 bytes. So that means we are wasting 4-bit, but 12-bit is stored in 2 bytes. In recent, like past 10, 20 years, most CT vendors have the large CT scale, basically not only using 12-bit, also you can using 16-bit. So one of the reasons using 2 byte 16-bit is reserved space, but for the future development. So when we using the 2 byte per pixel, we will get this number of storage per image, then 4.7 gig divided by this would be get around 9,000. And also remember the gig byte. The gig is a decimal scale, so it's 10 to the 9th power. All right, easy one.
All right, this question is up in the polls section, so you can go ahead and answer this one. Just want to remind and encourage everyone who has a question to ask it in the chat so that we can go over it at the end for the Q&A. Questions or responses are still coming in for this question, so we'll just give everyone another moment to answer this one before we go review the answer. All right, Beijing, I think we can go ahead and go over the correct answer.
The correct answer is C. From 1024 to 512, 1024 to 512, that's 2 times. Also from 8-bit to 16-bit, also 2 times. So 2 times times 2 times 2 times 2 times is 8 times. So correct answer 8. All right. Next, we are talking about network. Unfortunately, we only have 15 minutes. Hopefully, I can quickly rush through. For network, I want to point out 2 common terms. One called LAN, local area network. The other one called WAN, wide area network. This is a geometric concept. For WAN, like from campus to campus. For LAN, like within the same building or between different buildings, but within the same campus. A typical example is the Ethernet for LAN, also Wi-Fi for LAN. And for WAN, there are many different types. For our home, cable or files is commonly used. For business, T1, T2, T3, satellites, microwave is commonly used. And be careful of these terms, DSL, SDN, and POST. That potentially could be in the exam. Just know the term. This is an image of a classical router. This 2 part is using for WAN. This group of part is using for LAN. The network is in layers. In OSM model, there are 7 layers. In Radiation Oncology, we typically using TCP/IP. TCP/IP using 4 layers. This is the common hardware and software put into different layers. When we talk about address, also in layers. For example, MAC address is in the interface layer. IP address in the internet layer. The port is on the transport layer. And our host name, because we need to resolve by DNS, is on the application layer. When we talk package, also is layered. Our real data in the application layer will enclosed into a TCP UDP package by adding a UDP header. then this package will be enclosed into an IP package by adding an IP header. This IP package will enclose into the frame by adding a frame header. So now it's a layered approach as well. This is the typical trilogy setup with all the network equipment. This is the remote access computer. It's running on the application layer. This is the firewall or gateway from Juniper. It's a transport or internet layer. This is a small switch from Dell. It's running on the interface layer. The network cables all running on the interface layer. If we have a true beam, we do not have 3 equipment anymore. We only have 1. Also from Juniper, it's a firewall and gateway. And this part, if running in the switch mode, is running on the interface layer. Let's talk about the topology of the network. There are 3 types. One is a bus. That's typically used on the coaxial setup. The star, that's typically for the Ethernet. Basically, everybody, all the computers connect to a central unit, sometimes called a hub or switch. The other one is the ring configuration. Token ring is the common one. For Radiation Oncology, star topology is the one we use most often. Let's talk about the Ethernet cables. There are 2 types of cable. One is the straight through, the other one crossover. What we use typically is the straight through cable, or also called the patch cable. If you look at the wire sequence, the straight through cable is identical. The crossover cable are not. So that's how you can differentiate between the 2. When we use the crossover cable, when we connect computer to computer or switch to switch, the cable have different speed category. Commonly used one nowadays is Cat 5e, Cat 6, and Cat 6e. When we look at the link speed, be careful about the duplexing. All should support full duplex. If not, check your computer driver might not be turned on. This is some typical computer cable error. This, of course, this is the extreme example. This is the best example. So in this way, the reason is the noise coming from these untwisted wires. So the shorter this untwisted wire, less noise introduced to the cable. So when we suspect cable speed, check the cable condition, and also check the cable label, because Cat 5 cable only support 100 Mbps. That should not be used nowadays anymore. Let's talk about the internet address. 127.1.1, the 0.0.1 is the loopback IP address. That's used for diagnosis only. There's 3 classes of private IP address. Most of our computer using this private IP address because we do not have so many public IP address available anymore. One thing I want to point out, for Windows computer, if the DHCP failed, will automatically give an IP address of 169.254.0.1. And do not be confused. This is not the right IP address the computer is supposed to have. So if you see this IP address, that means the DHCP failed. This is some like a default port within the transport layer. A couple of things to mention is FTP 21, DICOM 104, file sharing is 445, and Microsoft Remote Desktop is 3389. When we talk about the application layer, we talked about the DHCP before. DHCP means Dynamic Host Configuration Protocol. This protocol is help the computer get the IP information or configure automatically. And a typical result is like this. The DHCP is enabled, then we have a least timing, and we get the IP address, default gateway, and the mask. DNS stands for Domain Name System. The main purpose is translate the host name to the IP address. In the application layer, also have web. For example, for wiring, our service portal is run as a web service, FTP and Telnet. FTP, for example, we can FTP file from Pinnacle to the Redcal. That's pretty common. In the application layer, there another commonly used is a network share. For TrueBeam, the iDrive is typically mounted the way transfer network share. The other example is in the RPM. The advanced for export is mounted on the D drive. Here is the list of the commonly used network shares, just for your information. Here is a real-time story. When we access the network share, we got this error message, don't currently have permission to access this folder. We need to check the share permission, the NTFS file system permission, and need to check if we have a firewall antivirus, and also need to check if the server and the client have the same version. And the other one is network share slowed down after a period of time. One lesson we learned is the minimum spec from the vendor typically not enough for good performance. So do not use the minimum spec, always use the recommended spec at least. And the other one is it's a Windows, so you need to reboot periodically. The typical setup is reboot per month. Let's talk about the domain and the Active Directory. Domain is a logical group or network object like a computer, users, and device, and share the same Active Directory database. Active Directory is a directory service developed by Microsoft for Windows domain network, used for centralized domain management. For wiring, there are 4 types of groups that's for wiring area. The Active Directory including user, computer, groups, printer, and share. Let's differentiate between domain user and the local user. domain user belong to a domain can access computer resources within the domain. A local user belong to local computer can only access the computer resource in that computer. Here's a story for the domain users. The symptom is RPM software have an error message that cannot lock patient database. The cause is the RPM upgraded. Unfortunately, the PC joined the domain after installation, then changed the default login from local user to domain user. And unfortunately, the domain user do not have the proper permission to run the RPM software. So solution is simple. Log in as a local user. And here's the way to change the default login from domain user to local user. Let's quickly talk about data security. Everybody gets annual training from the hospital regarding the HIPAA. By regulation, by HIPAA, we must take care of the ePHI carefully, make sure they are secure. Here are some common practice to protect our data. Lock our PC or mobile workstation. That typically means our laptop or the cell phones. Also, always log off the computer after using. Nowadays, most hospitals automatically log off your computer or lock your computer within certain time period idle. Another thing I want to mention about is for the antivirus. Antivirus is very important. Unfortunately, that's not well tolerated by the Radiation Oncology softwares. So we cannot have real-time virus scanning, or we need to add exceptions to the real-time scanning. So we'll skip this directory for scanning. Or another way is just do not install it at all, which happened a lot on some of the Mosaic computers, for example, the namers. For the data sharing, also need to be pay attention. The HIPAA compliant app, including the Box, Dropbox, OneDrive, Google Workspace, and Google Drive, plan to using the one approved by HIPAA. The USB safety, we cannot using our thumb drive so easily anymore. We must using a encrypted storage. So basically, only special type of USB drive can be used to store patient information. And if this drive is stolen, we need to report immediately. Here are the real-time example. One day, suddenly we cannot initialize the MLC interface, cannot treat any field with the MLC. So we have no choice to cancel the 4 days of patient. The reason is the MLC, we typically shut down the MLC workstation. Unfortunately, that day we left on by mistake. The night shift IT remote in and found out there are no antivirus software. So he just installed it. Unfortunately, the schematic installed with the default setting, they come in with the default firewall. Then the Mosaic connection was blocked by this firewall. So that creates this connection issue. the solution very simple, just uninstall the antivirus, then everything back to normal. Here, another antivirus example. When we, after the cone beam and shift in the true beam, we transfer back to Mosaic, or we get error said SRO conversion failed. It happened frequently. We took a long time to troubleshoot. Finally, we find out the real reason, that is the antivirus slow down the process in the namer and DICOM. So conversion sometimes will time out, then cause this failure. So solution is just uninstall this antivirus on the namer only, resolve this issue. Since we talk about the network, we should talk about the compression. There are two types of compression. One is the lossless, the other lossy. Lossless means you can completely reverse the compression, become the same as the original. Typically, it's a 1:2 or 1:5 compression ratio. Lossy compression is typically used in the JPEG. Let's talk about the transfer. We always talk about the bandwidth. What is bandwidth? Typically, it's measured by the BPS, bit per second, sometimes called 1 baud. Typically, we run with the lowercase. The other one is the BPS, same, but the capital B, that's a byte per second. So pay attention. When we using lowercase, it's a bit. Using uppercase, it's a byte. If we said we have 300 meg BPS of files, we know it's a bit because the lowercase. But what if that 1 gig internet, is this bit or byte? Typically, when we talk about the bandwidth, always bit, and also always using decimal scale. All right, let's come to the question.
All right, thank you. This question is up in the polls section. We'll give everyone just a moment to go ahead and respond. And Vijay, if you could read through the question, that would be great.
A CT image is 512 by 512 pixels and have 12-bit pixel value. How long does it take to transfer in 10 meg BPS Ethernet connection?
All right, thank you. So that question will just be up for another moment. And if anyone has any questions, you can go ahead and put them in the chat for the Q&A at the end coming up here shortly. We just have just one more poll question after this. So make sure you answer it live, because once it's down, you won't have a chance to answer it unless you're doing this at home from the WePast webinar library. All right, just another moment here. We see some answers rolling in. Okay, let's go ahead and review the correct response.
The correct answer is B, 0.5 seconds. First thing, we ignore the time image header, which contains the non-pixel information. And we talked about before, the pixel value, even it's a 12-bit, but stored as 16-bit or 2 byte. So total number of bit is 512 by 512 times 16. And we have 10 meg BPS. So we will have this byte times 8 bits per byte. then divide by 10 megabit per second. We end up 0.4 second. Typically, if we consider overhead, we can round up to 0.5 second. So it's 0.5 second. So also the trick part is still, even it's a 12-bit, but stored or transferred all in 16-bit. Let's go to the next question.
Okay, great. This one is up in our polls section, and this is the last question, I believe. Is that right?
Yes.
Okay. If you could go ahead and read that, that would be fantastic.
A CT image set of 120 slices was taken for brain patient. The bandwidth is 100 meg BPS per, from acquisition to storage with the lossless compression ratio of 1:4. How long does it take to transfer?
All right, thank you. So we'll give everyone just a moment here to respond. And again, if you have any questions for the Q&A, please go ahead and drop them in the chat. We'll be going over those shortly after the presentation is done here. We'll give everyone just another second to answer this question. All right, let's go ahead and review the correct response.
The correct one is C, 1 second. First thing, we can know the header, and we know it's a 2 byte per pixel. The total number of bytes is 512 by 512 by 2, then times 120 slices, then divide by 4 because the comparison 1:4. So this is the byte number. This many byte times 8 bit per byte, then divide by 100 megabit per second. So ending up 1.3 second. So closest one would be 1 second. Lastly, I want to give my acknowledge and also the reference listed. Any questions?
Yes, we have a couple questions here. Our first one is from Dustin. When designing a VM environment, it is common to overspec each item to be hosted on the VM, or is it expected that underuse of one item will balance out overuse of another?
Typically, the VM can be load balanced, and even the over spec is acceptable. That means even the budget much higher spec, but if we are not using that much, that unused portion can be used by some other VMs. So I'm not sure if I answered the question.
Okay, thank you for answering that one. Our next question here is, what comprehensive resources would you recommend for preparing ABR computing IT questions?
Unfortunately, ABR do not give a detailed syllabus, and also there are no real textbook on computer part yet. Actually, I was talking with McDermott, talk about if we should have a additional chapter on computer and networking. I think that might be in the next version.
Okay, thank you so much for answering that question. We have another question here. What's the difference between firewall and gateway?
For gateway, basically the major function is the relay. So we're moving data from one location to the other, from one network to the other. Firewall is selectively block the traffic.
Okay.
And so basically, go ahead.
Oh, no, I'm sorry. I thought you were done. You can continue.
So firewall is main purpose is block, pass the impacted traffic. But gateway is no matter how will relay the information.
Thank you for answering that question. Our last question here is, would there be another webinar, second part, which we have discussed that there will be, and part of the question is, will DICOM, et cetera, be covered?
That's up to the VPAS.
Okay, great. Well, we can discuss that with our content editor. So yes, there will be a part 2 of this webinar coming up, so please stay tuned for that. And thank you, Vijing, for presenting part 1 of this Radiation Oncology IT webinar. And thank you all for joining us for this free event hosted by WePast. For some of you who asked, this webinar will be available on our YouTube channel for the next week. So if you need to review this presentation, please be sure to check it out there. And if you missed that window and need to review it after this week is up, you'll be able to find this and many other recorded webinars on our WePast channel. And it's available to subscribers 24 hours a day, 7 days a week. So be sure to register through wepast.com to become a subscriber. And for up-to-date information about our upcoming webinars, be sure to follow WePast on Facebook, Twitter, and LinkedIn. And if you have a moment, you can help us improve future webinars by taking this short survey. All right, thanks again, everyone, and we'll see you next time.